Hey, everybody. Good morning. How are you all doing? Today, I'm going to be sharing a presentation on sharing skepticism and arguing constructively in math class. And normally, if we were face to face, you would experience the instructional routine that's at the heart of this presentation, and you'd be able to explain how the routine supports mathematical argumentation. But we are remote. So instead of experiencing the routine, you're going to get a walkthrough. Yeah, which is not ideal, but c'est la vie. So, first, a bit about instructional routines. These are designs for interaction that organize classroom instruction. And really, every experienced teacher is using some kind of instructional routine. You really can't be successful as a teacher if you don't have routines. Instructional routines are a little bit like a play in a football game. So imagine that everybody in the team knows the play. You all know what you're supposed to be doing during the play. It's not quite scripted because there's lots of variables, things change depending on what's going on, but you kind of know what's going on. You kind of know what's going to happen next and what's going to show up. The instructional routines that I use start with some supports for learners that we want to make sure are there to support them, to make sure that they're being successful. And we package those and put those together into a routine structure. And then when you reuse that routine, you get repeated benefit from that reuse. Another benefit of instructional routines is that you help sort of sharpen cognitive focus in the classroom. If you don't have instructional routines, kids got to think about a lot of different things. They got to think about what's going on and what am I supposed to do next? And is Johnny giving me the evil eye? All that kind of stuff. With instructional routines, it's not that those concerns go away, but they kind of can fade into the background. Kids know what's going to come up next. They don't know exactly how to solve the problem that's being shown up, but they know what the structure is going to be, and they know what they're going to have to be asked to do. They know what the task is asking them to accomplish. If you use an instructional routine of one kind, and I use a different instructional routine of a different kind, and we try to talk to each other, it's going to be harder. Whereas if we're using the same instructional routine, it's much easier for us as teachers to talk about teaching. So a really big benefit of instructional routines is it makes it easier for teachers to learn from each other and to really understand what each other is going through. So during the routine, if I'm going to share it with teachers, what I normally do is I have teachers to think like a student and speak like a student. So if you watch this presentation and you say, okay, well, I want to try this, but I want to practice it with my colleagues first, I recommend running through the routine and rehearsing it as if your colleagues are students and you are the teacher. And of course, because you're teachers and you're thinking about trying to use the routine, you're going to want to consider the routine at least a little bit. Have a little portion of your brain space available to think about what's going on and what the teaching is. Maybe take notes on a piece of paper or something. So I would normally start the routine by telling kids, what are we working on today and why are we doing this? So that kids know what the overall goal is for the day and they know why we're working on this particular goal. And when kids know what you're trying to accomplish, it's much easier for them to be able to participate meaningfully in that lesson. The routine has 5 major steps. First, kids solve a problem on their own, quietly, independently. Then they discuss their problem solution with their colleague. I'll get more about the idea that a problem solution is the same as an argument, but for now, just buy that, okay? Then we share and critique those arguments together. So the idea being that students get a chance to see other people's arguments and try to think about what makes those arguments work. Then, once they have some arguments up and they've been annotated, they choose one of those arguments to decide, I think that argument's the best, but here's how I would improve it. And then at the end, they reflect on learning with the goal of reflecting on the main why of the day. We are trying to get better at mathematical argumentation, so that's what I want to reflect on. I have a blank slide next, which just has the prompt. How can I make my reasoning and process as clear and convincing to others as possible? If you want kids to do a task, if you want them to know how to do a task, then you have to give the task and the prompt separate from each other, or they'll just start doing the task. Then I give the task next to the prompt, and kids can work. And something I often do here, depending on the difficulty of the problem, is I give kids a piece of paper with a task on it. Now, for some tasks, this is not a good idea. But if you want kids to be able to remember a complicated argument, then they need a place to record that argument. And I put a link to an example of one of these tasks and arguments here. So what I'm going to do next is I'm actually going to have you try to solve the problem that I'm giving here. So I want you to, in the next slide, I'm going to want you to pause and take a look at what the problem is, pause the video, and try to solve it yourself. So I'm going to move on. Here is the task. Get one of these expressions and match it to one of these two visuals. Figure out which of these expressions matches with one of these two visuals. That's the goal. And then remember that you're trying to make a really clear process for other people to be able to follow. Okay, so hopefully you paused. This particular task comes from New Visions for public schools. They call it connecting representations. There's a whole routine around just the connections. But if you're going to use this kind of task within the sharing skepticism routine, then you only really need kids to come up with one connection and one justification for that connection. Once kids have their connection down on paper, then you have them discuss that argument with someone else. And we give them some sentence prompts to make that a bit easier. I think this is true because, and this works because, and then, the partner is kind of should be a bit skeptical. How do you know that's true? Can you help me understand this part? Once kids have shared and you've gone around and listened to kids to see who you want to have present, you have 2 or 3 students with their partner present their arguments at the front. I use a particular structure for this, borrowing it from Grace Kalamanik and Amy Lucenta. It's not necessarily critical to use the same structure, but I really like it because I think it really gets kids thinking. So I'm going to share a video of using this pair presenting structure so you can take a look at it. So about 1.5 minutes, here's some video from an actual classroom using this pair presenting structure.
What do you think?
Okay.
We're definitely ready to do
Ready to do the second one?
Yeah, should we do it?
Did
The second one also.
they didn't match A yet?
No.
Okay, so let's have this group.
All right, so I need your attention. 5, 4, 3, 2, 1. So this group I think all of you had really great ideas. I'm gonna have this group present. Okay, so one of you is gonna come up and point, and the other one's going to speak. All right? And when you're speaking, you're going to say, "We noticed, so we," and then "we knew, so we." Okay? And the other partner is just going to point. So the person pointing doesn't speak. The person speaking doesn't point. So would you like to speak? Would you like to point as she speaks? All right. Thank you for volunteering. All right. So you can stand up, but again, only the person speaking can't point, and the person pointing can't speak. And the rest of you need to be listening.
Ashley, so go up there.
To what the speaker is saying.
Whatever Kat's saying, you're gonna just point to, okay?
So I think, we noticed that the expression number 2 combines with the vision number B because it's parentheses x plus 2, right? So all the visions and all the squares and rectangles will repeat 3 times since it's being multiplied by 3. And so the x, we believe would be the rectangular and the squares would be the 2. That's what we noticed. And so we knew to combine the vision B with the expression 2. Thank you.
Great.
Okay, so now you have kids, they're going to restate what other kids said. We're going to give them sentence frames to make it easier to participate. Kids have got to handle what the arguments are. Now they're going to choose an argument. Which of these arguments actually convinces them and why? So I'm going to show a couple of arguments up here so you can kind of go through this experience yourself. Here's one argument. We have some annotation. We've used the blue to make it clear that there are 3 rows. We've used the red to make it clear that each of those rows has an x plus 2 in it. I want you to imagine that discussion came out. We have another argument connecting the same representations. So notice that we've connected the same types of things, but we've done it differently. Here we've got the blue representing 3 x's and the 6 representing 6 squares. So these are 2 very slightly different arguments. In the first argument, we don't need to distribute to figure out what this expression connects to. In the second argument, we do. So you as a student would choose one of those 2 arguments. You would say, I think that's the right argument, and here's why. And then you would talk to your partner, and you would ask yourself with your partner, which argument did you choose? And can we make this argument even better? Is there anything missing in this argument? Is there anything that would make this less clear to someone else? Okay, so then they have some sentence frames, and they're going to share their connections with the room. You're going to have, again, 1 or 2 different groups, pairs of kids that come up the same kind of pair structure, and they're going to point at an argument and they're going to present it. I sometimes do this a little differently. Sometimes I'll be the pointer for pairs so kids don't have to come up again, but that all really depends on your own classroom. So we've shared the arguments. Here's the original poster. We've got a very simple addition. We just want to make clear what's X. Inner annotation, we want to make that connection really clear. So that's how we change the first argument. In the second argument, we realized that we didn't connect the 3 to anything. So we're just going to change the annotation very slightly. 1, 2, 3. And I would say that if you selected these 2 changes to share with kids, or to have kids share with each other, then your goal would maybe be precision around arguments. What exactly are we talking about in each of these arguments? So then when kids reflect about when constructing arguments, it's important to blank because blank. If you've met your goal, then you would expect to see kids putting in statements like, when constructing arguments, it's important to make sure my argument is precise because that makes it easier for other people to follow. Okay, once kids have reflected on paper, that's in the template, then they share their reflections with a partner. And that gives you a chance to walk around and see what some of those reflections are so that you can pick some that you want to use as examples for other kids. Because whenever we have work done individually, it's really important to get some of that work in front of everybody so that everybody gets a bit of feedback on their ideas and improves their own arguments. Quite often find that in the reflection, there's some really deep mathematical thinking that occurs, and it's really important for all kids to have access to that. Okay, that's the end of the activity. So initially, when you do that activity, you might find it takes 30 minutes, and then 25 minutes, and then the next time it's 20 minutes. And if kids know exactly what's next and you don't have to sort of tell them every step, you can probably do that whole routine in, I would say, consistently 20 minutes, and maybe for some tasks, 15 minutes. So that might be an opener. It might be a review. You might use it, I don't know, maybe you'd take a look at some stuff you did a while ago and see if kids are able to make connections across different strategies they've learned. Who knows? So I'm going to ask you to pause again. And what I want you to do is just think about, what do you think stays the same each time this routine is used? What do you think changes? I'm going to leave this up for a minute for yourself, so you can pause here. So what kind of tasks can you use? Well, New Vision's got a bunch of tasks for a different routine called Contemplate Then Calculate. And pretty much all of these tasks have the traits that are really important for this routine. There are sort of 3 main traits that I think are critical if you're going to be successful with the task that you've got within the routine. The first trait is that all kids have access to a solution of some kind. That you're not spending a bunch of time going around helping kids, just even get started. That's really important. The second trait is that there's a variety of possible solutions. You don't want just one way to solve the problem. If kids are really going to be comparing arguments and choosing arguments, they have to have choice. So they need more than one way to solve the problem. And you need a task where you can reliably be sure that some of your kids will solve it one way and some of your kids will solve it another way. maybe you take the task that you did yesterday and you've got two different solutions that came out of your kids and you give it to them again and they present their solutions. And maybe the work to present solutions has really already been done in the previous class. You can kind of shorten the routine a little bit. The third trait, and I think this is also equally important, is that after kids present their arguments, there should be something they can do to improve their argument. So if a task is too simple, or if students are really good at developing arguments, then you might need a task that's a bit tougher for kids so that when they get to the part when they're presenting their argument, that they might have something missing. There might be some way to improve it. I think that's really important. So another point which you're probably wondering is, how does this routine support mathematical argumentation? I mean, aren't kids just solving problems? How is solving problems related to mathematical argumentation? So I think this is maybe I don't know, maybe trying to think of a way of saying this. Every time kids solve a problem and they have a solution that they've written down, really their solution is a mathematical argument. They are going to show a sequence of steps, and those steps are amounting to a mathematical argument that shows that the thing that they've got as their answer is in fact the answer. So it's really critical for kids to be able to write down their work and to be able to present their work for someone else to follow. That's a really important idea for mathematicians. And in terms of solving a problem, kids probably don't realize that what they've done is produced an argument. When you think about solving an equation, one of the critical features of solving an equation is that each line in that equation is true because of some mathematical property. If I have the equation 2x equals 8 and I change that to x equals 4, well, that's a mathematical argument. Why am I allowed to divide by 2 on both sides of the equation? How does that preserve equality? When kids are arguing, what they often do is they start by forming some conjectures. And initially, kids really have conjectures and they have ideas about how those conjectures are connected to each other, and they try to produce a coherent argument. So your kids, if you're working on this, your kids are probably starting with constructing cases, let's say, looking at different examples. They're maybe validating each line of their problem-solving process. But it probably doesn't feel like an argument to them either. So part of the thing you can do with this routine is really make the argument structure lift off the page for kids. And that will make it easier for kids later when they're working on developing proofs or trying to show that two things are equal, etc. So this image here is quite useful when you think about the different ways kids can get into an argument, constructing cases, formulating conjectures, validating conjectures, generalizing, etc. And then to help yourself understand the sort of general structure of an argument, right? We've got some things that we know are true. We make some claims. We check to see is there anything that would dissuade this claim. We maybe have a rebuttal of some kind. Then we have some qualifiers because maybe it's only partially true. All of these things form part of mathematical argumentation. Okay, now normally I would stop and you would get a chance to ask questions about the routine. But yeah, this is asynchronous, so that's not going to happen. Instead, you can tweet to me. You can say, hey, @DavidWeiss, I got a question about the routine. I'm not sure exactly what you were thinking there. Or how you have any other resources? I'm teaching 3rd grade. I'm wondering about using this routine. What about kindergarten? Can I do this routine in kindergarten? I don't know. These are fair questions, and you feel free to contact me if you have questions about it. I think that this video is going to be uploaded somewhere, and there may be a chance for us to do some questions live Q&A afterwards. I'll look into that. So the routine itself, the general structure of the routine, where we have the instructions for kids, followed by the steps, followed by sort of 3 different portions or 2 different sort of, kids working independently, working with a partner, and then sharing with a room. I really got that work from Amy and Grace, who wrote this book, Routines for Reasoning. fabulous book. It's got some others routines in it. I think you'll really like it. And the idea of presenting arguments to each other to try to improve the arguments, kind of, I would say, adapted that from some work that the Nueva School was doing in San Francisco. If you have interest in other routines and want to learn more about how to use routines, here are some other resources. You can look up New Visions for Public Schools. There's a fabulous book called Choral Counting and Counting Collections, really good. Got a couple other routines in there which are particularly suited for, I would say, K to 8. TED.org, TEDD.org, has different routines. Again, a variety of different ages. And then All Ed has routines that are really, I would say, a little bit more content agnostic. So these are routines that you can use, especially if you're an elementary school teacher. You might want a routine that you can use in English class and in science class and in social studies. So All Ed, I think, has got you covered there. So here's some links. I've got my blog, my Twitter. I've given you my email address. And then I've got links to the handout that we looked at today, the template slides for the routine. So you don't need to make those. I'll give you a blank copy basically. And then I've been keeping track of some citations because maybe you're curious about what's the evidence that this structure really works for kids. So I've got some citations there if you're interested. So I realized after I did the first draft of this that I should probably answer some questions during the video. So I'm going to do that. Here are some questions that often come up when I do this workshop with teachers. The first one being, how often should I do this routine? And my answer is often enough to make it routine. So maybe in the first 2 weeks, you do it 4 times, let's say, 5 times, and then maybe once a week after that, or maybe once every 2 weeks. The key is that if it's not routine enough, then the benefits of it being routine won't occur, right? If kids are asking you, what comes next? What's the next thing we're supposed to do? I've forgotten. Then you probably need to do the routine more often if you want to get those benefits. Another question I often get is, how old should kids be? How old should they be when they're doing this routine? And I would say that I would probably wait until kids are able to construct, 3-year-olds construct arguments, right? But are 3-year-olds self-aware enough to improve the argument the next time? And having been a parent of a 3-year-old, do you want 3-year-olds to have better arguments? That's a different question. But maybe by the time they start school, maybe it's 2nd grade. Maybe it depends on your community. I would say you could probably do something like this routine right up into high school for sure, and possibly into college. Another common question that people have is, what about the annotation? I watched some video of somebody doing annotation and they make it look so easy, and it's actually not really all that easy. I think the key thing for me is that I have to connect the annotation to my goals and try to figure out what I'm trying to accomplish. So then I plan the annotation. I take a guess. What are kids going to do? You might think of the 5 practices, where the goal is to take things that, the 5 practices, right? The first you anticipate, then you monitor, and so on. So with the 5 practices, the first step is anticipation, and annotation becomes part of your anticipation process. Okay, and then other questions are usually a variety of, like, what if? What if the kids are stuck? What if a fire alarm happens, etc.? Well, to be honest, I really can't answer this question very easily for you because there's a lot of different what ifs, and they kind of depend on the contingencies of what's going on in your classroom, what's going on in your school, etc. But the nice thing about a routine is if it doesn't work one day, then do it again and make a tweak. Try it differently the next day. If you change everything about your teaching every day, it's very hard to learn from what you do. So the nice thing about routines is you're not changing everything. You might just be changing the task. And then if you make a different kind of tweak, then you really can improve your teaching. I remember a story about a teacher who was struggling with the reflection portion of a routine. They really weren't getting very good reflections. They were getting reflections like, paying attention to Stephen is helpful because he's always got the answer, which that might be true, but that's not a mathematical reflection. And he learned that he needed his reflection prompts to be more specific. Instead of paying attention to blank is important because blank, he said paying attention to blank in equations is important because blank. And that little tweak made a big difference. And it allowed him to connect the reflections back to his goals for the lesson. So the big picture, though, is that just try it differently next time. Try it again. Try to improve it. Try to work on it. That's what teaching's all about, isn't it? Okay, thanks so much. I really appreciate your time, and I hope I get some questions out of this. Thank you.